Good morning. Hopefully you can hear me pretty good. Today we're going to be starting 9-4, solving quadratic functions by completing the square. At any point, please feel free to pause, fast forward, do as you wish, okay? Our learning objective, we will be solving quadratic functions using a method called completing the square. We have one vocabulary term, which is completing the square. Basically, that's when we want to add a constant to a binomial of the form x squared plus bx so that the resulting trinomial is a perfect square. Okay. Well, what do we mean by a perfect square? Well, do you remember when we were multiplying binomials and we would have like, our little box here? Okay. And so if I started off here, the idea is that we're going to start off here at x squared plus 6x. And we got to figure out what number we can add that will give us a perfect square. Okay? So if we're doing our little box, if you remember, the first term goes in the first box. Good. And then if this is a total perfect square, that means both sides are equal. Very good. Which means that both of these boxes will also be equal. Now, both of them have to add up to be 6x, right? So inside, you're probably going to have 3x and 3x. 3 plus 3 is 6, right? So let's go ahead and let's play our little game and figure out if I have x squared here, x and x has to be right there, right? Therefore, x times what gives me 3x? 3. Same thing right here. And what does my perfect square end up being? 3 times 3, which is 9. So the number I'm going to add in there is that, because what ends up happening is that I know that this will end up being the same as x plus 3 times x plus 3, otherwise known as x plus 3 squared. Okay? So that's just a little taste. Let's go to our Cornell notes and let's discuss something really quick. Just kind of refresh our brain. Go ahead and put in your header for your Cornell notes. And I just kind of wanted to discuss with you x squared equals, let's say, 16. Can you think of two numbers that, or actually, can you think of a value for x that would make this equation true? If you said x is equal to 4, absolutely. But what if I tell you that there's another value that also makes it true? Can you think of what it is? Okay. So the other value is -4, because -4 times -4 is positive 16. See, here we have 4 times 4, that's 16, right? That's pretty good. But if we have -4 times -4, that's also equal to 16, because the two negatives make a positive. So whenever we take the square root of this, when we take the square root of x squared, and we take the square root of 16, remember, I'm just looking for two groups of something, then I end up with x could equal two things. It could equal 4, positive, or negative. And the way that we write that looks like this. This basically is saying, hey, we have x, and it could be positive or it could be negative. Okay? These are two values, two solutions. So I'm going to write down the rules for you. And It won't entirely make sense, but you'll have it to reference as we're going through the example. So just bear with me, okay? Here we go. Basic steps for solving, for completing the square. Better. Okay? The first thing that we want to really try to do is make number one, we want to have a equal to 1. What do I mean by a? Well, remember when we're dealing with quadratics, the standard form of a quadratic? Do you remember what it is? Ax squared plus bx plus c. So a refers to the coefficient of x squared. Okay. Number 2, we want to make room for c. Okay. What this usually means is that we are going to move our constant to the other side. Okay. Number 3, we want to add our perfect c to both sides. Okay. Once we do that, we rewrite our quadratic in the square form. Rewrite. Take the square root. Basically this for both sides. Remember that we can have a positive and a negative, oftentimes when we take the square root, and then we simply split and solve. Okay? So, let's go ahead and go to our example 1. Nice thing about the video is that if you're not done writing, you can absolutely pause it, finish writing it, and then move on to example 1. Let's go right here. Find the value of c that makes this a perfect square trinomial. Okay? So, again, a perfect square has sides that are totally equal. The first term goes in the first box. Very good. So that's going to go right here, x squared, right? And then these two boxes are equal. So what do you think is going to go in each one of those? If you said negative 6x, very good. How did we get that? We basically took negative 12x and we divided it by 2. When you do that, you end up with negative 6x. Okay, now that I have that, let's put our little GCF game. What is our greatest common factor? When I look at this, the greatest common factor is x. Very good. And therefore, what has to be right here? What times x gives me negative 6x? Negative 6. Okay. Therefore, x goes here. X times x is x squared. And again, negative 6. See how both of these sides are the same? It's because it's a perfect square. And as a result, what goes in this box right here? Negative 6 times negative 6, which is positive 36. Ladies and gentlemen, that is our perfect C, I guess is what I'm going to call it. Okay, that's the constant that's going to make this a perfect square trinomial. And so our answer is 36. Okay. Let's come up with a smarter way to do this, okay? Because, you know, what we did is in step one, when we were looking at our example one, step one, we looked at our middle term, otherwise known as b, right? Let me go ahead and write this out. So x squared minus 12x, okay, plus c. And we know the standard form in general is ax squared plus bx plus c. By the way, what's the value for a here? 1. Good, positive 1. So the idea is that we took negative 12 and we divided it by 2. And that gave us negative 6. You remember when we did that over here? Okay, the formula for that, instead of negative 12, we're going to use the variable b. It's basically whatever the coefficient is of x, the middle term. We divide that by 2. In step 2, what we did is we then, to get our perfect c, we said we took the answer to this, negative 6, and we multiplied it by itself, right? Otherwise known as negative 6 squared. And we ended up with 36. So essentially, that would be the same as taking b over 2, multiplying it by itself, otherwise known as squaring it. Okay? That ends up being our perfect c. This right here is the formula for the perfect c. Okay? Which is very important. Also, I want to talk to you about this. If I was to, in example 1, we end up with a trinomial that looks like this. X squared minus 12x plus 36, which can be rewritten as x minus 6 times x minus 6, which looks like this. Otherwise known as x minus 6 squared. So if I'm ready to go ahead and get this into the form of x minus 6 squared, okay, all I have to do basically is take my b over 2, because remember that was equal to negative 6, right? And just plop it in there. Okay, so what gets put in there, I can always look at the middle term, divide it by 2, and put it right in. Okay. Let's go ahead and practice a little bit more.